I'm Sudha Jamthe. Welcome to BUS 20, Stanford Continuing Studies program course on how to build a successful business with Internet of Things. If I get an OTA update from my Tesla, how do I know it's coming from Tesla? The same applies to all devices. How do you trust a device in this complex web of multiple products that interact with each other? Today we have Mrinal Wadhwa, CTO of Ockam, who's going to talk to us about Internet of Things and trust using blockchain. Mrinal has deployed complex IoT solutions for smart cities. In fact, he's deployed the largest set of IoT sensors for parking in SF Park, built a water leak management solutions for the city of Amsterdam. So with all this, he's figured out how to build trust in IoT. So, welcome, Mrinal.
It is becoming easier, cheaper, lucrative, and incredibly attractive for a lot of parties to go after IoT infrastructure. So the key is to make it so that a device would only trust a signed firmware update. This is an example from my old smart cities domain. Somebody crafted a radio message and broadcasted it in the city, and it turned on 120 tornado sirens. And it stayed on for a few hours around midnight on April 9th, 2017. In end of 2016, a bunch of guys who were trying to gain an advantage in the game Minecraft, they wrote a bot that used these 64 default passwords, like default was their password or password was their password. And turns out there were 600,000 devices on the internet that had some combination of those 64 passwords. So what they were able to do is get into those devices remotely and take control of them. Then that infrastructure was used by other parties to attack the internet. And they almost shut down the internet in several parts of the world. This is still being leveraged. In January 2018. It was used to attack several companies in the financial sector, and there have been several variants of this thing that have since been developed. What makes it worse is, this is a problem that hasn't gone away even till today. The reason is there is no way to fix all of those vulnerable devices because there is no way to deliver a firmware update and have the assurity that it took. One of the first things you would do if you're a malware writer, once you're in the device and you receive an update, you send back a message saying, yeah, I got your update, right? But you never actually apply the update. So how do we come up with these guarantees? So even though you may think you're building a benign little device, your product may become a tool for others. Here's another extremely scary example. Last year, this thing called North Pattaya caused $10 billion of damage. It basically was ransomware that got into your PC and locked the PC and said, give me money before I unlock. It went and locked PCs at Merck, the biggest shipping company in the world, at Merck, the big pharmaceutical company, at FedEx, and a bunch of these really massive corporations, and literally shut down operations for several days. But one of these companies recovered their system because somebody in Ghana had an electrical outage, and their computer was the only computer that wasn't affected. But you may say, okay, the ransomwares were about PCs. Well, they're coming to IoT devices. So imagine your house saying, pay me, I don't know, X dollars before you can be warm tonight. Somebody did build a $32 device, and they were like, why even build it? Went to eBay and found a piece of toy that had all the hardware they needed, and they just put the firmware in it. So they can now use this to hack any garage. This company, Pectron, builds key fob systems, and they're not only used by Tesla, but other companies, and their weakness was essentially they used a very weak key. Regulation is going to get really, really stringent. And what they're doing is they're looking at stuff that has already happened and making laws saying don't do that. What these laws don't account for is all the other things people are going to go figure out.
Can you talk about SB 327, the California IoT security law?
This law that California passed basically says don't build something that can be hacked. That's sort of what the language is. Do reasonable things to protect yourself. That's the thing we, as this group building cool, new, innovative IoT ideas, have to think about, right? So how can we build reliable and trustworthy IoT for our customer? Trust begins with knowing the source of a piece of data and being able to verify that a message you receive from that source truly is something that came from that source and it is exactly what the source said. So how do we get to know that source? So who am I? Device identity is so hard is because doing it correctly involves a lot of things. So let's assume you become a very successful IoT company and you're producing billions or tens of millions of IoT devices. The very first thing you have to ensure is that every device actually has a unique identity. So you have to give it some kind of number saying you're number one, you're number two, you're number three. But you can't have this number be truly too predictable. You have to kind of do things around protection against that. So essentially what you have to do is give each device an identity, but also give it unique cryptographic keys. And that's our mechanism for knowing that if that device signed this piece of information, then I know because of mathematics that nobody else could have manipulated this information. And only that device could have sent this information. But here's the mistake a lot of people do. So they'll focus too much on encryption because everybody tells them for security you have to have encryption. But encryption is keeping something secret. That is less of a problem. I can look at a parking space and tell you that it is empty, right? So secrecy isn't something you're going for in a lot of scenarios. What you're going for is the signatures on the data that are. Of course, in some scenarios, secrecy is important. You cannot have the same signing key in every device you ship. That becomes the logistical challenge. The logistical challenge is, if I'm producing tens of millions of these things, how do I deliver them unique keys and not compromise the keys along the way? So what happens in a lot of companies is they will put unique keys, but then they'll send out an Excel sheet from the manufacturer to the company saying, hey, here are all your keys. And so anybody over the internet who knows how to intercept email can get all the keys.
That's what I've heard. That's what I heard they do when they set up beacons in retail stores or factories.
They actually get the beacons done in China and they get a spreadsheet with it, giving
with all the keys.
With all the keys.
Yeah, this is incredibly
it's very classic.
Matt and I have spoken to some very, very large companies that just completely punt this problem, right? So the extreme thing you can do is say, okay, I will just not have keys in my devices, right? That's what most people do today. They'll just not have any kind of cryptographic security. The problem with that is that not only can you not trust the information you're getting from those devices, you can never be sure that those devices are something you can update. So that's the problem with Mirai botnet devices, right? So even if you send them an update, there's no signature you can get back on an acknowledgement, and so you can never prove that your devices actually got your update. And that becomes this massive challenge. So things that companies have been building for decades that are smart things but never connected, and suddenly some innovation team in that company said, oh, let's connect it to the internet, it'll be this really cool thing. And it often is. However, the problem is connecting it to the internet, it creates this massive surface area of exposure that they don't think about. So you have to give every device a unique identity, you have to give every device a unique cryptographic key, you have to worry about how this cryptographic key is programmed into the device and stored in the device, right? So there are a bunch of specialized hardware that stores keys in a way that nobody can remotely steal all your keys from all your entire network. These things are called trusted platform modules or trusted hardware or crypto hardware. You have to also do blockchain-ish things. You have to record what makes up a specific device, right? And if you guys follow the news around supply chain of electronics having trouble, that sort of falls in this realm. You need to know exactly what is in a particular device, not in a model of a device, but in a particular device. Because a lot of times what will happen is you give out an order to some company in China that has to manufacture a bunch of devices, and you have a spec, but they're free to replace components that kind of match the spec, right? And so what ends up happening is you define device number one, what goes to market to your customers isn't exactly that. It's a little bit different. And oftentimes people don't even know what that is. So you don't know what your customers really bought.
So it's not even done maliciously. It's just they may not have that particular part.
And this way they pick it from a different bin that meets the spec, right? And the problem is that other bin may be more vulnerable to attack than this bin. And those kinds of things happen. You should be able to record exactly what firmware was put in a device. You need acknowledgements on updates, etc. And then this is the sort of key message, which is every message, every piece of information you receive from that source must be signed. If it isn't, it just isn't trustworthy. And this is just the very, very top surface of this, right?
Sorry to interrupt, a quick question, but do you think any computer manufacturer is also doing any of this or some of this?
Yes, they are, right? So we're working with Intel a little bit, and Intel does some of these steps around their supply chain and also their cryptographic programming keys.
So if I buy an Intel CPU, or is it an Intel machine?
Intel CPU, right?
Okay.
And I don't know of the computer manufacturer, but Intel CPUs come with these things called EPIDs that they've been shipping in Intel CPUs since 2003 or something.
Yeah.
However, a lot of the software that is written for Intel computers doesn't take advantage of it. So even though that underlying identity exists, we still have a lot of over-layered vulnerabilities.
So I think the Intel, that's my thing, is like, isn't the MAC addresses usually unique? So in every device which you're talking about has a MAC address. Can you tee off of that? That's one question I had.
Yeah.
The second one I had was around in the pharma industry, they solved some of these problems using something called a GTIN, a Global Trade Identification Number. Is there any plan on the IoT side to have a GTIN kind of a identification number? So this way, using that unique number, you can track that device back to all the way up to the manufacturer.
Okay, so here's what happens. So yes, there exist unique numbers that identify stuff, right? There are serial numbers, there are MAC numbers, there are VIN numbers, there are a whole bunch of these standards that aren't, that kind of followed, right? Here's the problem with this. Let's say I am number 452, right? And I send you a message. And somebody in the middle takes my message and changes the number to 500 and replays my message to you. So you have no way of figuring out whether this message was manipulated along the way. So what a signature does is it runs mathematics on that initial packet that included my identity, my number, but it puts a signature at the end. So when you get the message, you look at the message and you verify the signature to see if this message is exactly what I sent you. Right. So numbering things is part of the problem because there's lack of standardization around it. However, numbering things doesn't solve the trust problem because numbers can be manipulated along the way.
Yeah, and that's the same problem they have in pharmacy also. It's counterfeiting. That's exactly
it is exactly this problem, right? And they'll put in stickers that look the same and have a different number and all that. Exactly. So machine identity is incredibly hard. So we, as the IoT community, have to get drastically better at solving this problem of provisioning identity and managing identities. And identity here isn't just one number, it is what is that thing? What is it made of? What are the components in it? What is the software in it? What cryptographic keys does it have? Who touched it at what time? All of that makes up the identity of a device, right? And we have to get better at it. This problem gets even worse because even in the simplest example of a device, just like, take your pet monitor, right? I design it. I give the order to some Chinese manufacturing company. They build 10,000 of those. Some other shipping company or several shipping companies deliver the device to me. I hire a contractor to write firmware for that device. that contractor hires subcontractors to write further firmware for the device. The device has software libraries that were written by other parties. The device went for an FCC audit, and somebody at FCC looked at the design of the device and checked whether it meets the right radio regulation or not, right? And then I give it to a retailer, maybe to a warehouse. So some folks at warehouse touch the device, the retailer touched the device, and then eventually the device ended in front of the customer, right? Even then, the customer turned the device on, but the network that is used to deliver messages from the device to my server that I wrote or my contractor wrote, that network is operated by other parties, the telcos, the low power wireless network, or, you know, in case of my building, there's Jim, the cool networks engineer who lives in the building, and he runs the building's network, right? So everybody, his name's actually Jim, but okay, so the problem is, so many parties are involved in making one device work. And this is a pet example. If you start thinking about the number of parties involved in a device that lives on the street over there, it is just crazy, okay? And this is not just me saying it, this is somebody from Vice President of Security Systems at ARM. He's like, complexity is one dimension of the challenge. There is a layering of technologies from the physical IP in which the key that will make the root of trust is embedded, all the way up to the application and everything in between. There also is complexity in the process to build all of these things, to provision them, to load the code, to load the keys. One of the biggest challenges is there is no standardization across the IoT world. The problem in the IoT world is that every vendor has their own standard. And that's by definition not a standard, but the whole community seems oblivious to that fact, right? So everybody's inventing new standards. And there's good intention behind that. People are trying to solve these problems, and they're complex problems. However, we're majorly suffering from this problem. And I recently heard somebody use the term, where IoT is in POC hell, right? And I so deeply relate to that term because I have been in way too many projects that are still in POC. All right.
I've heard that comment in a different context, as if people are not seeing the value of it, companies are not seeing the value of it, whether it is real. When they do a pilot, maybe they're not getting the ROI as they expected, that's why it's not going past POC.
That is certainly part of the problem. I mean, it's not the ROI of the solution. It often is the total cost of ownership of the solution that's where the pain typically is. So that is certainly part of the problem. But the other part of the problem is that if I am a customer of some IoT solution, let's say City of Palo Alto wants to buy an IoT solution to do smart parking, right? And so they hire a system integrator and say, hey, Accenture, build me a smart parking solution. Accenture goes and hires a vendor, let's say my previous company, Fiber, or this gentleman's smart parking solution. And so that's just, let's say that's the sensor. And the Accenture goes to Verizon, and Verizon gives them the low power wireless network, or Comcast gives them the low power wireless network. And then Accenture goes to Amazon, and they give them the server-side IoT platform, right? And now Accenture sort of piecemeals this whole thing together. Now the customer says, okay, who's going to give me an SLA on this thing, right? And Accenture says, I don't know about that, right? And every vendor in that pitch says exactly that, because no one vendor is in control of the whole picture. And so no one vendor is willing to take ownership of the whole picture, especially because it is so complex, right? And so that is a perfect segue into why I think blockchain is a great solution to these challenges, right? So let me define blockchain just to sort of level set. This is my definition, doesn't have to be everybody's definition. But my definition is, it is a decentralized system, so no one party runs it, that combines techniques from the fields of cryptography, economics and distributed systems to enable trust between several parties, right? That's the goal of blockchain solutions. Enable trust between several parties, in my opinion. And the techniques leveraged are cryptography, so you have to be able to have signatures on every piece of data you write to a blockchain. Economics, so you have to be able to build a system of incentives and disincentives. So if a device is behaving well, you can incentivize it, maybe give it some money, I don't know, right? But if it's behaving poorly, you can disincentivize it, maybe disconnect it from the network, right? And there can be automation around it. And distributed systems, because this cannot be something one party runs. Because if it is something one party runs, we come back to the problem of all this ecosystem of vendors that must come together to deliver this solution. They cannot trust each other and cannot make this thing work, right? That's the POC hell we're in. So it has to be a decentralized distributed system that combines cryptography, economics, and distributed systems to create this. An immutable, digitally signed, verifiable attestation log of everything that ever happens to a device, right? And it seems daunting because we have to do this for 20 billion or 30 billion, whatever number of IoT devices there are going to be. But we're good at doing things at that scale. We just need to automate this, right? We just need to make it so that we can create this infrastructure. But this is the foundation for a secure, trustworthy IoT, right? And in my opinion, if IoT isn't trustworthy, it's kind of pointless. And that's sort of the reason why companies wouldn't go actually spend real money on it, or customers wouldn't actually go spend real money on it. But if we have that immutable, digitally signed, verifiable log, we can answer all of these questions. Was the device made by a reputable manufacturer? Does the device have hardware-based cryptography and secure key storage? Does the device have unique keys? This was our key point, right? Has the device been audited by a security auditing firm? Is there a signature from the auditing firm saying, yes, we audited it and it's great? Is there a signature from FCC saying, yes, we audited it and it doesn't violate any laws? Are there any known vulnerabilities? So if I own a Linksys router today, right, the number of router companies that were affected by Mariah is basically every router company. So it doesn't matter. If you own an internet router today, and an attack like Mariah comes and is discovered by security researchers, there currently exists no mechanism for me to come to know that my device is now vulnerable, unless the vendor voluntarily tells me that. So if there existed this decentralized infrastructure where this entire thing existed, there could very easily be correlation. So if you found out that your router is vulnerable and you logged an event saying my router is vulnerable and 10,000 people did that, my router gets scored poorly, right? Gets something done to it that penalizes it for that bad behavior until it applies a software update, and then it can get back to its old level. So does the device produce science data? Can it sign firmware acknowledgements? Does the device have latest firmware? Who installed the device? Who provisioned the device? These are reputations of the provisioning companies themselves, right? So if there comes to know that we all come to know that a particular provisioning company, when they installed our smart streetlights, were installing a little bug in them. Well, which streetlights are vulnerable? That question is correlated with what that installation company is. So we need to be able to ask these questions. And that immutable, decentralized ledger of what all was done to every device in the world is what will help us get there. So this auditable, signed history of a device that no one party can manipulate becomes the foundation of trust in data from that device. We can use it to derive a trust score, right? And your trust scoring algorithm may be different from my trust scoring algorithm, and that doesn't matter, right? We all need to be able to have this data to get to those scores, right? You can almost start imagining like a Yelp for every device in the world, if you will, right? That's sort of my mental model of something like this. So once you have this foundation of identity and trust, we can build safe, mutually signed an acknowledged firmware update. So both parties can say, yes, I, the software vendor, say this firmware update should be applied. The device can acknowledge, I, the device, have now taken the firmware update, right? So we can build that once that infrastructure exists. We can build secure automated device onboarding. So this is an interesting point that nobody kind of thinks about. The last time you installed an IoT device in your home automation system, how long did it take?
You're absolutely right.
15 minutes.
10, 15 minutes.
15 minutes. If there are going to be 20 billion of these things, there aren't enough 15 minutes to install those 20 billion, right? That's a problem. Onboarding needs to be automated. Onboarding needs to just figure out that I am in a HomeKit enabled device and this is the protocol I need to do it. If you have that foundation of the identity and trust in a device, two devices can figure this out, right? We can build the infrastructure for secure automated onboarding. And we can, of course, this was our goal, we can build reliable mission critical applications. We can solve the problems for that farmer, we can solve the problems for that self-driving car company. We can, of course, then design interoperability protocols that enable all of these sort of things just magically work with each other. Why does this work on this infrastructure and why doesn't it work today? The reason it doesn't work today is that even if I know the protocol of this other device, I don't really know whether I should be sharing data with it or not, right? So if there exists an identity and trust infrastructure underneath, whether or not I should trust this other device can be figured out because Mrinal owns device 1 and Mrinal owns device 2. These two devices are allowed to talk to each other. These kinds of automated reasonings become feasible. And if you take it a step further, you can have machine-to-machine real-time transactions. And because we're in the blockchain world, you can have machine-to-machine payments, and these can be micro-payments. So a appliance could pay the grid could pay the appliance, right? All of those incentive systems become feasible. In fact, you can imagine all sorts of crypto-economic incentives and disincentives that are now baked into the system because the cost of a financial transaction is reduced to like pennies or tenths of a penny, right? And so because it becomes this small, you can reason about every transaction involving some kind of as a service exchange, right? And then eventually, this is sort of why I'm in it, right? I dream of future worlds where there can be autonomous systems. I'm very passionate about getting there, right? And these autonomous systems can be as simple as my home figuring out, my current mood and setting or whatever. But this stuff should just work, and it doesn't currently. And so that's the problem I'm interested in solving. That's the problem we're trying to solve at Ockam. So Ockam is building this decentralized, blockchain-based IoT infrastructure for trust and identity.